Yeah, we were discussing about the PN sequence, right? What it is and how we are going to generate that PN sequence. So, any one of you, is it possible to say what it is? What is pseudonomous sequence? Yes, I expect answer. So, I think in brief, I said what it is. How do we generate the pseudonomous sequence in the previous class? Yes, even with the
The
slide. Yeah.
sir, it is called as M sequence, sir. For L is equal to 2 power m minus 1 number of bits can be generated for M stage. That is, if M is equal to 3, we have if we have 3 stages, then we can generate 7 codes, sir. It
Yeah,
is
7 bits. We can generate a pseudonomous sequence having a length of 7 bits, right? Okay. So what you said is exactly correct. So the sequence length depends on the number of shift registers, right? So this is what the relation, uh, the sequence length, which is denoted by capital L, which is equal to 2 power m and minus 1, where m is the number of shift registers, right? If I have a 3 shift registers, then I can say, so 2 power 3 minus 1. So 2 power 3 is 8. So 8 minus 1 is 7. So I can say the M sequence or PN sequence length is of 7 bits. Okay. So basically the PN sequence is known as what? Is a pseudo random or pseudo noise sequence. Okay. It is basically a sequence of ones and zeros with certain autocorrelation properties. So let us see what are its properties and all in the upcoming slides. So as of now, just you should be able to say it is a sequence of ones and zeros with certain autocorrelation properties, right? And then I said about the sequence length. How does it related to the number of shift registers? And so this is the general diagram of M stage shift registers with linear feedback. Okay, so here I have written M number of shift registers and taken the feedback at some shift registers and done the modulo 2 operation, right? So the output of that modulo 2 is given as input to the shift register. So to begin with, I think I explained this in the previous class. How do we generate this sequence, PN sequence, right? So I think I expect any one of you to say from your end, how do we generate this? Let me hear. Let me spend some 2 minutes time. Then I can go to the next one. So let me ask some person from my end specifically. Suag, can you explain, man? Suag.
Yes, sir. I'm just looking at it.
Yeah. Can you explain?
Do you want me to read it or explain, sir?
Uh, Instead of reading it, I want you to explain your understanding. Reading is one thing.
Yeah. Yes,
So if you explain, then I can understand that you have understood how this circuit works, right? Yeah. Is it possible to say?
sir, I'll take time, sir. Not,
You take time. Mm, then yes. What about any anyone independently, voluntarily can say? Yes. Is it possible to say Aditi? Yes, Aditi.
Yes, sir.
Yeah. Can you explain this circuit? How does it generates PN sequence? Yes, because I spent in the last class almost 10-20 minutes on this. It is very simple to understand.
Sir, can I explain, sir?
Chandana. Yes, ma. Aditi, you want time?
Yes, sir.
Yeah, take time. I think Chandana has come voluntarily to explain. Yes, please, Chandana, go ahead.
So the initial state considered is 1 0 0, where the 1 is the output of first flip flops, 0 is the second, and third flip flop is also 0. So the output will be 0. And in the next, when we give the second clock pulse, the first flip flop output will be shifted to the second, and the second will be shifted to the third, and third will be given as the output sequence. And then the first output and the third output are modulo 2 added, in the sense those two are XORed and the output is fed as the input for first flip flop. That is, 1 XOR with 0 will give output as 1, and that will be fed for the first flip flop. And again, the second clock pulse continues the same process. So,
Okay,
so
good.
here M is 3, so 2 to the power of 3, 8 minus 1, so 7 is the length of the output sequence.
Okay. Okay. Yes, anybody else? Yes, I'm asking anybody else is interested to say how Chandana has said. And even I have given assignment also for the other circuit. I hope everybody might have submitted. I will check the GCR. Yes, in the same way how Chandana has come forward, others can also say. What about
Sir,
Girish?
you have the answer for that sequence,
Yeah,
so we can recheck.
yeah. Answer I will check. Yeah, as of now, yeah, I will give the answer also. Maybe that depends on what initial states you people have taken, because I asked you people to take from 0001 to 4 ones, right? Yeah,
Yes.
depends on that. Yeah, definitely. Yes, anybody else? Is it possible to share your understanding quickly? Yes, I was asking about Girish. Girish?
Sir.
Explain ಮಾಡ್ತೀನಪ್ಪ. Can you explain, man, the circuit? How does this circuit generates the sequence?
Yes, sir.
Yeah.
So when we give input to the flip flop, sir, first flip flop.
Yeah, you talk a little bit loudly, man, so that I will be able to hear. Girish?
Sir,
Yeah.
can you hear, sir?
ಇನ್ನೂ ಕ್ಲಾರಿಟಿ ಇಲ್ಲ. Yes. Yes, what happened? Girish? Yes, what about Ram Sai?
Yes.
Can you explain, man?
Sir.
Yes, what Girish, you want to explain?
I'll do it.
Yes, Ram Sai. I asked Ram Sai. Yes, is it possible, Ram Sai? Okay, fine. I think let me just say revise from my side. So what I said with the given circuit, I have taken the initial state of the flip-flop as 1 0 0. Okay, and I have taken the feedback output that is from flip-flop 1 and flip-flop 3. I am doing modulo 2 operation of that, and I am feeding output of that as input to the flip-flop 1. Okay, this is my configuration. So when I apply a clock pulse, okay, so first clock pulse, what happens? So when the initial state is 1 0 0, right? So during that time, I am taking output at the output of the flip-flop 3, right? So hence I am writing the output sequence for that state as 0, because output of the flip-flop 3 is 0, right? So when I apply a clock pulse, what happens? It is getting shifted, right? Isn't it? So means whatever is there in flip-flop 1 will move to flip-flop 2. Then whatever there in flip-flop 2, that will be moved to flip-flop 3. And whatever there in flip-flop 3, that will move out of that. So with that, I am getting the output sequence as 0. Now, so output of flip-flop 1 is what? 1, right? And that is XORed with 0. So 1 XOR with 0, that will be 1. So now that will be fed as input of flip-flop 1. Means now the content of the flip-flop will be what? 1 1 0. Hope you're understanding that. So this one, whatever there in flip-flop 1 has been shifted to flip-flop 2, and whatever there in the flip-flop 2 0, that has been shifted to flip-flop 3, and whatever there in flip-flop 3, that has been shifted out, right? Then what is the input to the flip-flop 1? So XOR of x1 and x3. So x1 is 0, x1 is 1, and x3 is 0. So 1 XOR with 0, that will be 1. That will be given to flip-flop 1. Hence, now the sequence is 1 1 0, right? So when I apply the clock, so it is getting shifted. So whatever there in x3, that is flip-flop 3, that will come out. So now also it is 0, right? Then for the third clock pulse, what happens? So x1 is 1 and x3 is 0. So 1 XOR with 0, it is 1, right? So that will be given to the flip-flop 1. Then whatever there in flip-flop 1 has been shifted to flip-flop 2. That is 1 is shifted to x2, and whatever there in x2, that is a 1, right? So that has been shifted to x3. So now all are 3 1 1, right? So when I apply a clock, this one will come out of that, right? So that is 1 I am getting as the output sequence. Then now for the fourth clock pulse, what happens? X1 is 1 and x3 is 1. So 1 XOR with 1, that will be 0. So that 0 will be given as input to the flip-flop 1. That is why, so 0 is there in flip-flop 1, right? Then whatever there in flip-flop 1, that will be shifted to flip-flop 2. Means 1 was there, that has been shifted to flip-flop 2. And in flip-flop 2, 1 was there, that has been shifted to flip-flop 3, right? And that 1 will be coming as an output, here 1, right? So for the next clock pulse, so again, x1 is XORed with x3. That is, here x1 is 0 and x3 is 1. So 0 XOR with 1 is 1. So that will be fed to the flip-flop 1. That is why, so it becomes 1 0 1. So this 1 will come out. That will be my output sequence bit. So like that it goes. So after 0 0 1, again it starts repeating, right? So with the 3 bits and with this feedback, so this is what the sequence I get. If I change the feedback, then the sequence will be different, right? Instead of taking feedback from output of the flip-flop 1, if I take the feedback at the output of flip-flop 2, then the sequence will be different, right? That is why it is called a pseudo-random sequence. And even the state of the initial state of the flip-flop can be taken any one of these 7 states, okay? So with the initial state as 1 0 0, this is what the output sequence is. That is 0 0 1 1 0 1 is my PN sequence. If I take the initial sequence as 1 1 0, then my PN sequence will be what? 0 1 1 0 1 0 it will be, okay? Hope you are understanding what I'm saying. You have to start from that bit. So as I said, the initial state, it is arbitrary. You can take any one state. Okay. So with respect to that, I think I gave this as the assignment to solve. Here, 4 flip-flops are there, right? So obviously you can think that 2 power 4 minus 1 will be 16 minus 1. So PN sequence length will be 15. So 15 bits will be the PN sequence length. And with this feedback, means here I am taking flip-flop 3 output and flip-flop 4 output. I am doing modulo 2 operation. I am feeding that as input to the flip-flop 1, right? And with this initial state, 1 triple 0. Okay, so this is what the sequence I can say. 1 triple 0 is the initial state, right? Whatever there in X4, that will be appearing as the output sequence because I'm taking output at the flip-flop 4. Okay, for the first clock pulse is that. Then for the second clock pulse, what happens? X3 XOR with X4. So here X3 is 0, X4 is also 0. So 0 XOR with 0, it will be 0. So that will be fed as input to the flip-flop 1. That is why 0 comes in flip-flop 1. Then it is getting shifted to the right side, right? So 0, 1, 0, 0. Then for the next clock pulse, so X3 is 0 and X4 is still 0, right? So 0 XOR 0, that will be fed to the flip-flop 1. So it is getting shifted. So 0, 0, 1, 0, right? For the next clock pulse, 1 XOR with 0, it is 1. So that is why that 1 will come here. Okay, so 1, 0, 0, 1. That will be the state. And whatever the output of flip-flop 4, that will be your output sequence. Okay, so like that you can keep explaining for all the 16 states. Okay, so with the initial state as 1 triple 0, this is what the output sequence is. That is what? Triple 0, 1 double 0, double 1, 0 1, 0 4 ones. Yes, Nareen, what is the initial state you have taken? Yes, Noreen. Noreen? Hello?
Yes, sir.
Yeah, what is the initial state you have taken?
Article 0001.
Okay, if you have taken 0001,
Yes, sir.
if it is a 0001, then your sequence will start from this point. That is 1, then 3 zeros, 1 double 0, double 1, 0 1, 0 3 ones. Is that the sequence you got?
Yes, sir.
I'll repeat once again. If your initial state is 0001, your PN sequence will be what? 1 000, then 1 double 0, double 1, 0 1, 0 triple 1.
Yes, sir.
Is that right?
It goes
Yeah.
on till 111, no?
I didn't get you.
So if we take initial state as 0001, the last condition will be all ones.
All ones. Okay. Yeah. Similarly, what about others? Means if you take this 0001, so with respect to this, what happens? X3 X4, no. So 0 XOR with 1 is 1, right? Means that 1 will come to the flip-flop 1. So then, this state only will come. Okay. I think last state will be this 00 11, I feel, not all ones. Noreen, if I am correct.
Sir, it's 1 triple 0 1 double 0 double 1 0 1 0 1, right?
Can you repeat? See, if the initial state is 0001, right? So what happens? The next state, what will be? So 0 XOR with 1, it will be 1, right? So 1 will come to the flip-flop 1.
Yeah.
And these 3 zeros will be shifted, right? Means that is 1 triple 0. This is the second state. whatever I've written here. Right? The next state will be what? Again, 0 XOR with 0, it will be 0. Means this will be the second state. You will not get the last state as all 4 ones. Okay, just you are taking 0001 as the initial state now. So it will go here first. Means the last state will be 0011.
So can you just repeat that sequence once, the final answer?
Yeah, with the initial state as 0001, okay,
Yes.
the PN sequence will be 1 000 1 00 11 01 0 111.
Yes, sir. That's the one.
Okay.
I got the same.
Yeah. Yes. What about others? Other students? See, at least 15 students, because 15 different states are there, right? I expect so 64 is the strength. So if each 15 in group, if they take one initial state, so many different PN sequences you should be able to write. Yes, hope how to generate PN sequence. Got the clarity? Okay. Let me say what are the properties of this pseudonymous sequence. So these M sequence or PN sequences are used in spread spectrum communication, are usually periodic. Okay, so it is a periodic sequence only. Whatever we are getting here, and even in the previous example, what I've shown, it is a periodic sequence. Means for every with this 7 bits I'm saying, no, it's generating. So it keeps repeating after every 7 bits, okay, or 7 cycles, I can say. That is why it is called periodic. Okay, here with respect to this, after every 16 cycles, it repeats. Okay, that's why it is called periodic. So the major task of the pseudonymous sequences are spreading the bandwidth of the modulated signal to the larger bandwidth, then distinguishing between the different user signals utilizing the same transmission bandwidth, because every user will be using the same transmission bandwidth. So this pseudonymous sequence will be able to distinguish their information. Right? Means it will be able to distinguish the information from one user to another user, because then the maximum length sequence is a type of a cyclic code that represents a commonly used PN sequence. So the sequence is periodic with period L. Then each period contains, so this is important, each period contains 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. Okay, so just you check with m equal to 3. So if m equal to 3, so 3 minus 1 is 2, right? So 2 power 2 means 4. So whatever the sequence you have generated, you just check whether there are 4 ones, and number of zeros will be what? So 4 minus 1, 3 zeros. So 4 ones will be there and 3 ones will be there. Sorry, 3 zeros will be there. Okay, just check with this. In this sequence, so there should be 4 ones. 4 ones are there, right? 4 ones and 3 zeros are there. So that is one property. Okay, so understood that point? Each period, I said, contains 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. So always the number of ones will be 1 more than the number of zeros. That is the first property what we said. Okay, hope understood? I said each period contains 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. So with the given example, I said when m equal to 3, the length of the PN sequence will be 7 bits with the initial state 100. I think that one only I have taken, with the initial state 100. I have shown what the number of ones will be 4 and the number of zeros will be 3, right? Similarly, you can check for this. Here it is 16-bit, right? So check number of ones will be how much it will be. Yes, how many number of ones should be there? So 2 power m minus 1, right? M is 4. So 4 minus 1 is 3. So 2 power 3 is 8. 8 ones should be there. So here it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 ones are there and 7 zeros are there, right? So 1, 2, 3, 4, 5, 6, 7. All right. So 2 power m minus 1 minus 1 zeros will be there. So that is the one property of this PN sequence. As I said, always the number of ones will be 1 more than the number of zeros. Yes, my dear students, is this clear? Hello?
Yes, sir.
Okay, ma'am. Thank you. Always Namita's response. I don't know what happened to other people, whether they will be there with me or not. I don't understand. They never say yes or no. Okay, so first property is known as the balance property. So what I said, in each period of a maximum length sequence, the number of ones is always 1 more than the number of zeros. So just now I told that, right? So number of ones will be 1 more than the number of zeros. That is known as the balance property. And you should say with that equation, L is equal to 2 power m minus 1 is the number of ones, and 2 power m minus 1 will be the number of zeros. Okay. The second property is known as the run property. Okay. So let us try to understand what it is. What is run property? First we need to understand what is run, right? What is run? And then we can say among the runs of ones and of zeros in each period of maximum length sequence, 1/2 the runs of each kind are of length 1. Okay. 1/4 are of length 2. Then 1/8 are of length 3, and so on, as long as these fractions represent the meaningful number of runs. Okay. So what do you mean by run? How do we define that? So run is series of ones and zeros grouped consecutively. Okay, say for example, for the sequence, whatever we have considered, this is a 00, 111, 01. In this, okay, I can say there are 4 runs. Okay, this sequence has 4 runs. First run is what? This is 00. Second run is 3 ones, and third run is 0. Fourth run is 1. What I said, run means a series of ones and zeros grouped consecutively. That is known as a run. Okay. Yes, is this clear? So with that, whatever I told in the previous slide here, what I said, 1/2 the runs of each kind are of length 1, then 1/4 are of length 2, 1/8 are of length 3, and so on, as long as these fractions represent meaningful numbers of runs. So let us try to find that. So with this sequence, how many runs are there? I said there are 4 runs, right? So 1/2 the runs of each kind are of length 1. Is it possible to say? Is it having that? Yes, because the 2 runs, that is 0 and 1, right? These runs are having a length of 1, right? Because it is a single bit, single 0 and single 1 are having a length, I can say 1, right? Then what is the next one? 1/4 are of length 2. 1/4. Here 4 runs are there. So 4 by 4 is 1. So one length is having a length of 2, right? So one run of length 2 bits is there, right? So 2 zeros is there. And then, so one run is having a length of 3 bits. Okay, because 3 ones are there. Yes, hope understood this property. What is run property? First, we need to say what is run. Run is what? How do we define the run? A series of ones and zeros grouped consecutively. Okay, for the given example, what is sequence? 00, 11101. I say this sequence has 4 runs. Right? What are those 4 runs? 00, then 111, then 0 and 1. So these are the 4 runs I say. Out of 4 runs, 2 runs will have a length of 1. Okay, that is 0 and 1. And one run is having a length of 2. And then one run is having a length of 3. Okay. In the same way, is it possible to say for this sequence, how many runs are there in this? Yes, I expect answers from people. People should come voluntarily and answer this. How many runs are there? Yes, my dear students. Hello.
8 runs are there.
8 runs are there. So this is one run, then 2, then 3, 4, 5, 6, 7, 8 runs. Okay, very good. Yeah, out of 8 runs, how many runs are having a length of 2, 1, and 3? Yes,
Sir,
quickly.
one length of 3, one length of 2 length of 2, one
Not
length
2
of
length.
4.
2 runs are like that. You have to tell in terms of number of runs. Okay,
Yes,
see
sir.
what I said here. See, 2 runs are having a length of 1 bit. Okay, one run is having a length of 2 bits, and one run is having a length of 3 bits. Yes, Akshay only sorting, right?
One run
Okay,
of
do one thing. All of you take 1 minute or 2 minutes time. Please note down this sequence properly and segregate the number of runs and think whatever the rule I said. What rule I said? Sorry. Yes, what is the rule I said? I was telling now, one half the runs will have each kind, one of the runs of each kind are having a length of 1. Just verify that whether it is obeying that rule or not. Then 1/4 are having a length of 2, 1/8 are having a length of 3. Just check that for that sequence. I think in this it is holding good now. So 2 runs are having a length of 1. Means with respect to this statement, one half the runs of each kind are having a length of 1. Right? Out of 4 runs, so 2 runs are having a length of 1. Then what is the next statement? 1/4 are having a length of 2. 1/4 means 1/4 of 4 is 1 only, right? One run is having a length of 2, right? Then what I said next one? So 1/8 are of length 3 and so on, as long as these fractions represents meaningful number of runs. You just think about that. Means 1/8 are having a length of 4, a length of 3. If it is having a, if it is representing, that fraction represents a meaningful number of runs. You just think about this example. Here, one run is having a length of 3 now. So because 1 by 8 into 4, so 4 and the 4 2s are 8, 1 by 2. So 0.5 runs are not there, right? Minimum run length is 1, right? So that will not holds good for this. So that is why. So the one run is having a length of 3 bits. Okay. So hope you able to say with respect to this example, with respect to the sequence. Yes, quickly. Yes, is this properties are interesting or not? If you involve, I think it will be interesting. If you don't involve, then you cannot. In that matter, anything. Okay, only if your involvement is there, you can succeed. If your involvement is not there, then it is a failure only.
Sir, in the previous example, you said it's not following.
What is not following?
You said the rule is not applicable because minimum length is 1, but you got 0.5. Sir, if you consider 0 and 1 as separate, it is applicable, sir.
0 and 1 is a separate run only.
Yes, sir. They have given 2 runs of length 1. That is 1, 0 and 1, 1.
Correct.
So 0.5 and 0.5 together, you will get 1 value.
Correct. Yeah, that is what means. What is that? 1/2 the runs of each kind are of length 1, right? So that is holding good now here. So 2 runs are having a length of 1 bit, right? 0 and 1. Then what is next one? 1/4 are having a length of 2, right? Means here one run is having a length of 2 bits, no? 0, 0. 2 zeros. What I'm saying. Yes, man.
Yes, sir.
Actually, then what is the next one? 1/8 are of length 3, right? 1/8. So with respect to that, so 1 by 2 is the fraction, right? As these fractions represent meaningful number of runs. So yeah, you understood my point. 1 by 2.
Yes, sir.
1 by 8 into 4. 4 is the number of runs, no? 4 runs are there. So 4 ones are 4 twos are 1 by 2. But yeah, 0.5 is not the length of the run length, no? In that sense, I said.
Yes.
So here, with respect to this example, so one run is having a length of 3. Yeah, what about this for this sequence? 000, 1, 00, then 11, 0, 1, right? 0, 1, 0, then 4 ones. So how many runs are there? Already Chay has said. Totally 8 runs are there, right? So out of 8 runs, just check 50% of the runs are having a length of 1. Means 4 runs. I should have a 4 runs which are having a length of 1.
Yes, sir, we have.
We have, right? That is 1, then next 0, then 1, then 0, isn't it? So 4 runs are having a length of 1. Yeah, then what is the next one? 1/2 is done, right? Then 1/4 are having a length of 2. Just check that.
We have 2 runs of 2 bits.
Yeah. So do we have two runs are having a length of 2 bits, that is 0, 0 and 1, 1, right? So that is also fine. So two runs are having a length of 2 bits. Then next is what? 1/8, right? 1/8 are having a length of 3 bits. So that is also holding good, I think, right?
Yes, sir.
Yeah, one run I am having a length of 3 bits, that is 3 zeros. That is also fine, right? One run is having a length of 3 bits. Then the last one is having a length of 4 bits, that is 4 ones, right? Yes, is this clear with that example?
Sir, but the last one, like 4 bits we have no, sir. It should be 1/16 of length. Is it?
Yeah, 1/8 are of length 3, till that is fine. Then, yeah, 116
One run
into
of
8.
4 bits.
Uh,
So again, it will be a 0.5.
that is what means that fraction does not represent the meaningful number of runs, na?
Yes, sir.
In that way. If it is representing a meaningful number of runs, then it will obey this rule. 1/2 will have the runs of length of 1, 1/4 will have a run of length 2, 1/8 will have a run of length 3, and so on. As long as those fractions represent the meaningful number of runs. Yes, that is the known as run property. So balance property, I said what it is. Then run property is done. Then the third one is the autocorrelation property. Okay. Yeah. Yeah, with respect to this example, hope we're able to see now. Yeah, I think. Yeah, with respect to this example, what is that sequence I've taken? 1 0 1 1 0 1 0. So how many runs are there? 1, 2, 3, 4, 5, 6 runs are there, right? Yes or no?
Yes, sir.
So this sequence has 3 runs of single 0, right, and 2 runs of single 1. Okay, and 1 run of 2 ones. Hope you got my point. The sequence has 3 runs of single 0, right? This 0 and this 0 and this 0, and 2 runs of single 1. 2 runs of single 1. This one and this one, and 1 run of 2 ones. It's this, right? 2 ones are there. So in a maximum length sequence of length 2 power m minus 1, so there are exactly, what do we say, 2 power m minus of p plus 2 runs of length p for both of ones and zeros, except that there is only 1 run containing m ones and 1 containing m minus 1 zeros. Okay, so there is no run of zeros of length m or ones of length m minus 1. That is, the number of runs of each length is a decreasing power of 2 as the run length increases. Yes, just take with respect to this example and try to understand what it is. Okay, so I will come back to this. Let me say about the third property, which is autocorrelation property. So as of now, I think 2 things are clear. One is what is balance property. Another one is run property. So third one is the autocorrelation property. So I think Yeah. So what is autocorrelation property is the autocorrelation function of a maximum length sequence is periodic and binary valued. Means if the period of an M sequence is having L chips, okay, which is what is that L? L is equal to power M minus 1 we say, where M is the number of stages in the code generator or shift registers in the code generator. So the autocorrelation function of an M sequence is periodic in nature and it assumes only two values. So that is why it is called binary valued. Okay. That is, so let me take this generalized explanation of this autocorrelation function property. So how do we define that? So it is defined in terms of the bipolar sequences, that is Cn. So I can say RC of M is equal to summation n is equal to 1 to L Cn, then Cn plus M, where the value of M can vary from L minus 1 and greater than 0. So L is the period of the sequence we say. Okay, so N value can vary from 1 to L and the M value can vary. It will be less than L minus 1 and greater than 0, right? So the sequence CL is periodic with period L, and the autocorrelation sequence, which is denoted as RC of M, is also periodic with period L, we say. So I think, yeah, with this, okay, still it is with the mathematical equations. I don't know if I take example, I think we'll be able to get that clarity. Fine. So before that, let me finish this. Then you can correlate how the value is, means how this autocorrelation is periodic and is having a binary value. Okay, so the ideal autocorrelation sequence, which is denoted as C suffix n, right, is what we say RC of 0 is equal to L and RC of M equal to 0 over this duration when the value of M is less than L minus 1 and greater than 1. And the M sequences, the autocorrelation sequence will be, so RC of M is equal to L when M equal to 0 and it is minus 1 when the value of M lies in this range. So for long M sequences, the size of the off-peak values of RC of M relative to the peak value, that is RC of 0, that ratio, that is RC of M to RC of 0 will be equal to minus 1 by L, we say, and which is small. So therefore, what we say, M sequences are very close to ideal PN sequences when viewed in terms of their autocorrelation function. So I think this, whatever I said now, can be clear with the example. So this is what the example I have taken it here. So let me say the PN sequence is Cn, which is what? 001101. Okay. So here there are 7 bits, right? Yes. I can write the value of n as 7. So in that I take first one as C1, this is C2, then C3, C4, C5, C6 and C7. Okay, so try to understand the generalized expression and with this example. Okay, I wrote RC of M is equal to what I wrote in the previous slide. Here, RC of M is equal to summation n is equal to 1 to L Cn and Cn plus M, right? So let me say here how it is done. So by taking that, then I said RC of M is equal to as two values. One is L when M is 0 and it is minus 1 when the value of M is less than L minus 1 and greater than 1. So here the sequence, that is C1 is this one, right? Then C2 and C6, right? I denote that as by minus 1 because it is 0. Okay, I represent 0 by minus 1. Then C3, C4, C5 and C7 are having a positive value, that is 1, right? So what is RC of 0? Means when M is 0, right? I get RC of 0. So RC of 0, you just substitute M as 0, right? So the value of N is varies from 1 to L. Here what is the value of L? L is 7, right? So just when N is 1, right? Since M is 0, what do you get? So first First product term is C1 and C1. Hope you are understanding this expansion. I am just expanding this summation term. One is Cn, another one is Cn plus m, right? So the value of m is 0 in this sense, right? So first product is what? C1 into C1. The next product is when n is 2, it is C2 into C2 because m is 0, right? And third product is C3 into C3. Fourth product is C4 into C4. Fifth one is means when n is 5, it is C5 into C5. Then when n is 6, it is C6 into C6. And when n is 7, it is C7 into C7. Hope this is clear. RC of 0. Then you substitute the value of C1, C2, C3, C4, C5, C6, C7 in this. So I said, what is C1? No? C1 is minus 1. So minus 1 into minus 1. What you will get? Plus 1 you will get. Then C2 is also minus 1. So minus 1 into minus 1. Again it becomes plus 1. Then what is C3? C3 is plus 1. Right? So that is why it is written 1 into 1. So it is 1. Then C4 is also plus 1. So 1 into 1, it is 1. Then C5 is also 1. So 1 into 1 is 1. Then C6 is again minus 1. So minus 1 into minus 1 is plus 1. Then C7 is plus 1. So 1 into 1 is 1. So hope we are getting this point. So first one is what? Minus 1 into minus 1, I said plus 1. Then next one is also plus 1. Right? So if you sum up all those, you'll get 7, right? So RC of 0 is equal to 7. Hence I say, so when m is 0, this autocorrelation value is equal to the length of the sequence. That is why I written RC of m is equal to L. Yes, my dear students, is this clear with this example? RC of m is equal to L I am getting, right? So where L is the sequence length, which is 7. Yes, is this point clear? Then I need to check when the value of m lies in this range, that is L minus 1 less than or equal to L minus 1 and greater than 1, it should be minus 1. So I have taken here the value of m as 3, okay, RC of 3. So with that, you expand this summation, means the value of m is 3, no? Right? So substitute the value of n from 1 to L. So first product is what I get when n is 1 and m is 3. So C1, then C4, no? M is 3 and n is 1. That is why I written first product as C1, C4. Next is when n is 2, so it is C2, then 2 plus 3 is 5, right? So C2, C5 I have written. Right? Next is when n is 3, it is C3, so 3 plus 3 is 6. So C3, C6. So next product is what? When n is 4, C4, so 4 plus 3 is 7. So C4 into C7. Next is when n is 5, so C5, so 5 plus 3 is 8. Right? So 8 is nothing but what? You need to think after 7, again it come back to 1, right? So that is why it is written C1, C5 into C1. Then when n is 6, so C6 into 6 plus 2 is, n is 6 and m is 3. So 6 plus 3, 9. So 9 is what? It is nothing but 2. So that is why it is written C6 into C2. Then, yes, is this clear, this point, whatever the multiplication I have done? Hello? Then just substitute the value of C1, C4. See, C1 is minus 1 and C4 is plus 1. So minus 1 into plus 1, it will be minus 1. Then C2 is minus 1. Then C5 is plus 1. So minus 1 into plus 1, again it is minus 1. That is what here it is written minus 1. Then C3, C6. So C3 is plus 1 and C6 is minus 1. So plus 1 into minus 1, it is minus 1. Right? C3, C6. Then C4, C7. So C4 is plus 1 and C7 is also plus 1. So plus 1 into plus 1 is plus 1. So here it is plus 1. Then C5, C1. So C5 is 1 and C7 is also, C1 is minus 1. So 1 into plus 1 into minus 1, it will be minus 1. Hence it is written here minus 1. Then C6, C2. So C6 is minus 1 and C2 is also minus 1. So minus 1 into minus 1, it becomes plus 1. So here it is written plus 1. Then C1, C3. So So C1 is -1 and C3 is +1. So -1 into +1, right? C1, C3. So C1 is -1 and C3 is +1. So +1 into -1 is -1.
Sir, it should be C7 and C3, sir.
Wait, here I think while writing superscript is subscript is written wrong, I think. First is right, second is also right, third is also right, fourth is also right. So when it is 5, 5 plus 3 is 8, no? So 8 I will be written as 1. So this is also fine, C5, C1. Then when n is 6, so 6 plus 3, right? I think here subscript is written is wrong while writing. So let me change that. So when n is 6, right? So 6 plus 3 is 9. One is C6, another is C9. So C9 is nothing but what? So this is 7, right? This is 8, this is 9, means C2. Yeah, C6, C2 is correct, is written. C6, C2. Then when n is 7, right? When n is 7, so 7 plus 3, it is 10, right? This should be 7, not 1. Right? It should be 7. And then 7 plus 3, it is 10. 10 means this is 8, 9, and this is 10. Means it is C3. That is correct. Okay. So here C7 and C3. Yeah. Fine. C7 and C3 both are +1. That is why it's +1 only. Then C6, C2. C6 is -1 and C2 is -1, right? That is why it's +1. Hope this is clear. Here is that subscript was a mistake. Okay. Yes, is this point is clear? Hello? Yes, I'm not getting response. Is this clear? This product, all the terms. Here, one term subscript was mistake. Okay. Hello. So -1, -1, -1, and here -1. So 4 -1s are there. Then 3 plus 1 are there. So -4 plus 3, it will be -1. So RC of 3 is equal to -1 I'm getting, right? So with respect to that, I can say RC of M is equal to -1 when the value of M is less than or equal to L minus 1 and greater than 1. So it is holding this generalized expression of autocorrelation sequence with respect to this example. Okay. So this is how we say. So when M equal to 0, autocorrelation sequence length will be is equal to the sequence length, and when M is not equal to 0, its value will be -1. So that is why when M is 0, I'm getting the value as 7, and when M is not 0, I'm getting the value as -1. That is why I say it is having two values. Okay. So that is done by, to explain that we have taken this sequence, and this is how we get the value of RC of M. So I think I will take up this in the next class. Okay.